You can so take a seat. Okay. Good afternoon to everybody. Welcome to this session, Getting the Data. We have 5 presentations, so we start sharpness because we have more time for question after each presentation. I remember to the presenter that we have 50 minutes and then 1 question time, always. The first presentation is made by Tim Duffy. Where is my experience with Atom and WFS download service, the Scottish Spatial Data Infrastructure. So the floor is yours.
Thank you, Carlo. Good afternoon, everybody. It's quite warm, isn't it? I know it's warm under the lights here, and it's certainly warm down there when you're listening to talks. Last year, Hugo promised us that the next Inspire conference was going to be somewhere warm, and we fantasized that it was going to be in Crete, and I had to tell him yesterday that he did not lie. It's really hot Aalborg. I presented last year, and I'm representing today the Scottish Government, currently called, along with my colleagues Shona Nicol and Alex Ramage, who's here in the audience if you want further questions asked. And last year we presented on the basics of the Scottish spatial data infrastructure with regards to metadata catalogues, and this year, like many of you, we are moving on to experiences with Atom and Web Feature Service download services. A bit of background though. The Scottish spatial data infrastructure is an open source, minimal but just enough infrastructure consisting of 4 elements: metadata catalog, metadata editor, recently updated, view service, client viewer, and harvesting information down to the current UK member state, the government in Whitehall, and beyond to the Inspire geoportal. View and download services, as the rest of Inspire, are in a federated scenario. Each data provider provides their own services and metadata, and the Scottish Government translated into legislation the Inspire regulations. We have a lot of experience with the metadata, and we have a UK national metadata standard called Gemini, now version 2.2, but that is, of course, is Inspire compliant, and we're looking forward towards the end of this year to upgrading it again with the new Inspire metadata that is being discussed at the moment. There are various metadata editors that produce this metadata. We produce guidance to all our data providers within the Scottish Government and the public authorities within Scotland, specific to Scotland, and so they get on with producing this. And here's a picture of our metadata, discovery metadata catalogue. This is a co-funded project between the British Geological Survey, the Scottish Government, and Adina from the University of Edinburgh, who are actually hosting this GeoNetwork open source based catalogue. It's been publicly available for a long time, and now it has many web map services in it and many data sets. It has approximately 348 metadata records. That may not sound like a lot, but we only provide metadata records for something that actually has got a service as a matter of policy, a data web service. And today it has approximately 10 download services, experimenting with the new Inspire, relatively new Inspire download technical guidance, 8 of which are Atom services and 2 which are Web Feature Services version 2.0. Those Web Feature Services supply currently just 2 or 3 Inspire spatial object types. I'll get back to those in a moment. The Atom services tend to provide lots of layers of data, and we'll look at that in a moment. Okay, what happens to the information in that Scottish portal? Well, it does get harvested down to the UK national geoportal, which uses the OGC standard for harvesting the data down. And from there, it is harvested every night to the EU geoportal. And as I upgraded a record on Friday, I thought, oh, goodness me, they've turned the harvester off because it's the Inspire conference with an updated record. But in fact, they haven't. It's now there. Other portals and applications within at least the Scottish public authority environment use this metadata and these services, such as the Scotland's Environment Web portal, which has just been republished and is really quite sophisticated, and it uses this metadata live, and it uses the web map services that are available from that central core spatial data infrastructure. So that all works. So, to today's topic, some of the first Atom download services available from Scotland. You can't read this very well, but that does say Scottish Government Human Health and Safety Download Service Atom Feed. So they follow the guidance, they've produced an Atom feed, and when it appears in the Inspire portal, I'm showing you pictures of everything actually available in the Inspire portal today. This is, of course, the demonstrator prototype portal that Angelo Quaglia is responsible for, and he always does wonderful things and get things working. He shows the metadata in a suitable fashion. We have the resource locator to actually the top-level Atom file there. And I think we'll go on. And the spatial datasets metadata resource titles show that there are in fact two resources or Atom data sets available. One is community health partnerships and one is NHS health boards from this individual Atom file. An interesting point is we did start with one Atom file with lots of data subfeeds that would have lots, say 20 or 30 different types of data from this institution, but from the Scottish Government. But we seem to be moving towards more specifically focused Atom files now that just have one or two theme-specific areas. Community health and NHS, National Health Service health boards, so they're related. This seems to be the way it's going with Atom files. And when you click through using on this Inspire portal, you get to the full service metadata record with things like resource abstract and lineage, etc., and the conformity statement. We are not providing Atom files with interoperable GML according to schemas, and so we are not conformant, but we are providing as-is data, which is the common use of Atom files, commonly in shapefiles. That is to say, this resource locator will eventually end up, if you click through, and that's the beauty of it, you can actually just click through as a human user rather than the computer getting to it, you can actually see what you're getting to. So when you do click through to the actual Atom file, you get a picture like this. If you have carefully constructed your Atom file and you've included a bit of HTML to make sure that it does work with a variety of browsers, because these things do not always work. Atom does not work as well as you would like in all browsers, but it works pretty good. And I'm going quiet here. You can see you're given options to actually click right through to the media type shapefile. You can click through to the metadata relating to that data set, and there's your health boards and there's your community partnerships. So you're clicking through, and eventually you do actually get to a zip file of your well-known shapefiles. Now, of course, shapefiles, as everybody in the room probably knows, is not just one file type, it's about 5 or 6 minimum. So here we have 1, 2, 3, 4, 5, 6 files all zipped up in a packet. So the Atom file data feed is effectively going through, have I just lost that? Yes. Is effectively going through to the zip shapefile. Can you hear me? At the back there? Can you hear me? Okay, right, keep that. Used one of these before, sorry. Now we'll move on to another example. This is one from my own institution, the British Geological Survey based in Edinburgh. Inspire data feed, an Atom file, again. We have a lot of coupled resources here. We've got 4 coupled resources. In other words, we've got 4, not 2 as in previously. We've got 4 related data sets being offered. And again, I say degree non-conformant, but good for actual use by real people until we move on to web feature services. So again, we can click through on the Inspire Geo portal to the full metadata. There's your infamous, if you like, conditions for applying to access and use, limitations on public access. And when we click through, we find that we do indeed have 3 layers, if you like, or 3 data sets. And we can, their resource abstracts are there to be read. And now this is the fun thing. I mentioned Angelo Quaglia and the prototype Inspire Geo portal. You never know, he's always finding new ways of getting something really useful and working. If you actually load this up in Inspire Geo portal, you find that he is measuring the performance of that download of that Atom file. Without telling anybody or documenting or anything, he can actually tell you it's going to download at a reasonable level now, according to the download performance guides. Now, of course, for an Atom file, that effectively is like a zip file coming across the internet, so you're unlikely to be too slow to do that, but it's rather fun that Angelo has actually put those performance criteria there displayed in the Inspire portal. One of these nice little surprises you get on the Inspire portal. So that's what this more sophisticated atom file looks like when you get here. So you click through to your dataset feed, and I'll just point out there's one 65K geology, British National Grid, and ETRS 89. In other words, most people providing atom services will want to provide at least 2 projections, and they are considered in the atom world as 2 different data feeds. You're always going to be wanting to provide an ETRS 89 one, the standard Inspire projection, and of course you're almost always going to want to provide your local national projection. So that's why we always have at least 2 files with the same data feed. And when you click through, you get to your actual shapefile zipped up, just sucking into your favorite desktop GIS, and lots of different file types there. There we go. Now, more excitingly, moving on. Some of the first web feature services version 2.0 available from Scotland. The first is from ArcGIS for Inspire, Annex 1 transport theme, as is GML. Some of you will know there is this ArcGIS software called ArcGIS for Inspire, and in fact for Annex 1 it can provide the actual Inspire conformant schema. We haven't gone as far as that today with this Transport Scotland dataset, but rather like the atom files, we're providing as is, but very simplified GML. That is to say, there's been no transformation, the topic of the previous talks in this room. It's just as found in the corporate database, which happens to be a geodatabase one for Esri. And it creates this web feature service. It is version 2.0 conformant, and therefore it's Inspire conformant. But the GML is very simple. In fact, it's actually, although it doesn't declare it, it's actually simple feature level 0 GML. There's the famous extended capabilities required to make a web feature service Inspire compliant, with direct links back to the dataset metadata and the service metadata, full service data. There's an example of the fact it is actually offering quite a number of projections. Not too many, but quite a number of projections. The point is this software can reproject this WFS on the fly, and that's important to see and to know about. We're all familiar with web map services which reproject to different projections that we like to use. This is the GML actually coming out in a number of different projections that is set up when you set up the WFS. But the feature type is just basically a generic name, Trunk Road Network January 2014, nothing very sophisticated. However, and Alex is very proud of this, you're not supposed to actually render web feature services, and web feature services in GML, of course, are supposed to be read by computers, not by humans. However, you can actually render this sort of as-is GML, this simple feature GML, by open source software like QGIS or by ArcMap Desktop, and there it is. And for us who come from Scotland, and happen to know that Alex works for Transport Scotland, we can actually believe that that is a sort of a map of Scotland with the major trunk roads in it. So that's a visual quality checking that is actually working. It looks about right. That's what Scotland sort of looks like in abstract. Moving on, finally, to a fully featured web feature service 2.0, again from the British Geological Survey. In the abstract, we are declaring that this service is delivering mapped features specified by geologic units, the geologic history of which is recorded by geologic events. Why am I saying that? 2 minutes to go. Why am I saying that? I am saying that because those are Inspire feature types, spatial object types. We are delivering them not in the Inspire recommended schema, which is quite simple, but we're delivering them. Remember that Inspire law doesn't require you to use Inspire schemas. You are required to deliver in some form mandatory spatial objects, at least mandatory, and geological surveys like to deliver a lot more than just in Inspire. So we're using a complex property schema called Geoscience Markup Language, which has been talked about earlier in this conference, to deliver these, and there's actual real Inspire feature types, and we believe they're correct, and we believe if there was actual software to do the abstract test suite on this service, it would actually pass, but we can only check that by reading at the moment. There's been a lot of talk this year about them getting on with abstract test suite actually using it. We believe that service will actually pass as a genuine Inspire geological service. That's what it looks like, extended capabilities. Here's your definition of your geologic unit and your map feature types, your actual spatial objects, in human readable words, and that will do for now. Thank you very much.
So we have a time for one question or two questions.
You stun them into silence. I told you it was hot in here. Charlie.
No, I give you questions. Tim, a question for you.
Oh yeah, once you actually know, just a minute.
Yeah, just quickly. You not mentioned, I think so, when you're talking about the double FS extension capability file, you're talking the version, the reduced version of the extension version of extension, because we have two different types.
I understand you. I forgot to mention, by the way, that the web feature service software here, version 2.0, was GeoServer. The latest version of the open source GeoServer software can actually do Inspire complex property web feature service 2.0 services quite recently. This is part of this research. What he's asking is the extended capabilities, does it contain all of the metadata for the service metadata record, or just what is called scenario 1, a reference to the full service metadata record? And in the United Kingdom, we always just like to refer to the full service metadata record, which is in the CSW catalogue. And the reason we like to do that is because we're lazy, is you have to have that record in a CSW catalogue. Elsewhere, there's no point in repeating the metadata. If you repeat metadata in two places, then you're likely to have issues with keeping it up to date. So we don't use the scenario 2, we use scenario 1. Thank you.
Thank you.
Now we proceed with the second presentation by Jiri.
Polacek. Can you hear me?
Yes,
I
talking
will
running for free by service, challenges and obstacles. What? No, this is the
no?
I think
that one. Yeah, this one, yeah.
Okay.
Thank you. Good afternoon, ladies and gentlemen. My name is Jiří Polacek. I work for the Czech Office for Surveying, Mapping and Cadastre. And my presentation is very practically oriented. I would like to share with you our long-term experience with free online services we provide. And first of all, I'll try to explain why is the situation in the Czech Republic a little bit specific in comparison with most European countries. Briefly, what are we running and how we do it. Another topic is what is the real need of Inspire services, especially free services. And finally, I'll tell you some real stories from Operation Run. So, specific situation. We launched a new database. Since 2012, we run so-called RUAN. It's the basic registry of territorial identification, addresses, and real estates. And the content of RUAN is covers Inspire themes, cadastre parcels, addresses, buildings, administrative units, or better to say, these themes are a subset of RUAN data. So we were expected to harmonize data and run download services, Inspire harmonized download services at the end of 2012. Furthermore, RUAN data is open data, so available for free for everybody, even for commercial reuse. So we decided that even Inspire download services and the digital cadastre maps will be available for free as well. And as the source information systems, there's the cadastre information system and information system of territorial identification are being run in an online mode. We decided that the final solution for Inspire services, that's the publication database, will be run online as well. And you will see later in some charts how does it work. Certainly this solution has some positive and some negative effects. Definitely positive is that we can use our online services in a number of our applications. So 3 of them are very well known in our republic. That's the viewing cadastre application, public remote access to RUAN data, and our branch GeoPorter viewer, because it's free for everybody. Some of them are for registered external users and other for internal office users. That's very simply how does our technological infrastructure look like. In the upper part, it's information systems run by the Czech Office for Surveying and Mapping and link with cadastre. It's cadastre information system of territorial identification, and they feed with data the basic registry and publication database. In the lower part, there are information systems and activities run by the Land Survey Office, and everything, I mean data, services, applications are available via our branch GeoPorter. What is important, upstairs runs everything online, while the Land Survey Office is using ETL concept. And briefly, Inspire workflow. So from the source information systems are some database tables replicated into the publication database in 2 hours period. Inside this period is necessary conversion to the Inspire data specifications proceeded, and via map server are viewing services and download services and viewing cadastre application provided. What are we running? If you are interested in details, what are we running, please visit presentation of my colleague Petr Souček on Friday morning. Briefly said, we run harmonized view and download services for cadastre parcels, addresses, and administrative units themes. For download services, it's both direct access, that's WFS 2.0, and pre-prepared sets, GML 3.2.1. Furthermore, we run some national extensions for administrative units and addresses themes. And what's important, we have a 6-year experience with running free view service for the cadastre map. And speaking about this view services, because it's without need of registration, we don't know 2/3 of our users. But what we know is that the biggest consumer of the view services, it's our office itself, and the biggest, the application viewing cadastre consumes almost 1/4 of computation power, and that's why it is the most frequently visited governmental web page in our country since 2004. And other external big users like utilities, banks, projection and engineering companies do not cross 1% of usage. Some statistics, this is average monthly demands for viewing cadastre application. Now we can monitor approximately 2.5 million visits monthly with more than 400,000 unique IP addresses and approximately 5 terabytes of data downloaded. The linked WMS are approximately 10 times less, but as you can see, the demands are still extremely growing. And what I would like to say is that according to the regulation on the network services, there are some accessibility parameters. One of them is that 20 parallel users should get response better than in 3 seconds. So this we reached after 2 years of operational run. Nowadays, we monitor in rush hours approximately 450 parallel users. We run direct access download services. This is a chart for parcels, but those services are not used so much as we expected at the beginning. And there are several reasons. The first is that the most software companies are not prepared for the WFS 2.0 on the client side yet. 2 years after we were obliged to run this. On the other hand, RUAN open data contain more information. Everybody can download it, and it contains especially buildings. And from clear reasons, we didn't start download services for building yet. So here is a graph how that open data from the basic registry are downloaded. It's more than 1 million files monthly, approximately 0.5 terabytes of data. Operational aspects. We found that it's not possible to guarantee availability and responses for free services, and certainly the biggest troubles were caused by the application of viewing cadastre as the biggest consumer of those services. So after several weeks, we launched our WMS services. It was March 2008. There was a case of execution on property of Prague Castle written into the cadastre. And if you clicked in this image in some electronic newspapers, there was a link to our application with the St. Vitus Cathedral. And what happened within 2 hours, the load of the system increased 5 times. The weak place was internet connection. We crashed and we had serious troubles for several days. Another case, you can't hear it. I was promised that it will. Oh, it's okay. I will translate it to you. It's our president of our office, Mr. Večeře. It's the news, evening TV news at Czech TV. The issue is the new cadastre law, and the reporter asked our president, what should people do to convince whether they still own something in cadastre? And the answer is go to our web page and click on the icon of viewing cadastre application, and they did it. So what happened? Within a few minutes, we monitored almost 40,000 hits per minute with more than 12,000 parallel users. Well, I'm proud to say that even the application and the linked viewing services were terribly slow. We survived, and after some 40 minutes, everything came back to normal situation. And I can go to the conclusions. It's okay. So first of all, as you have seen, running free online services is a real challenge, sometimes a bit thriller, but I can say generally a successful story. I don't know what is the real need of free Inspire services like viewing service for parcels or auto imagery. But I'm pretty sure that it's much, much higher than the accessibility parameters defined by the implementing rules. It is difficult to use free services for guaranteed application. In other words, is the goal of Inspire to have some guaranteed applications in serious cases like floodings? If so, we can't use free applications, free services for it, and it should be divided in future. And finally, as you have seen, some Inspire services are in a real operational run with a lot of linked users. I know that it's necessary to change many things, especially in technical guidance, but please, this must be, the timing of the changes must be done with the respect that the users will have the chance to switch to it. Thank you for your attention.
Okay, thank you. We have time for 2 questions. Some question for the floor? No question? Okay.
Actually, one question is, because you have these high demands, what's your infrastructure in terms of servers that you have behind it? Or you're not using a cloud-based infrastructure, but you're using, because you mentioned the bandwidth?
Yes, there are, for those services, there are three quite good servers with some proxy, and another one is prepared for some special cases.
Okay, thank you.
Okay, one more question? A question? Pass to the next one. So now we have Simon Jirka, with using OGC source and Inspire download service for observation data.
Okay, thank you very much. Okay, so now it should work. Thank you very much for the introduction. I'm going to present here a bit of a report or an outlook on work that has been done on a project recently we did at 52 North together with the JRC. It's a project that has been run in the context of the ISA program with funding from the ARENA context. And the aim was to look at the technical guidance for OGC download, for Inspire download services, and look how they can be optimized for observation data, namely by using the OGC sensor observation service. So the quick agenda, I will have a look at the motivation, why did we do that, then introduce a bit of the sensor web basics very roughly, then go quickly over the proposed update for the technical guidance document, point you to the most important changes there, have a look at the implementation, which is available as open source software, so that you can take that and try out what we have specified there, and then have a short conclusion. So the motivation was really to look at how to deal with observation data, because observation data is relevant in a very broad range of different application domains. That can be hydrology, if you have discharge data, water level data, could be air quality, where you are dealing with topics like ozone. There's even at the moment this e-reporting directive, a very hot topic where countries have to deliver data to the European Environment Agency, weather monitoring, atmospheric conditions, even humans as sensors, traffic information, geology, not all Inspire topics, but just to give you a rough overview in which domains this could be relevant. And looking at the available download services, Atom, WFS, it was concluded that there was still some gap to deal with this more dynamic type of data, which has also special properties, special metadata you need to provide. And there's also such a relevance then for several of the Annex 2 and 3 themes where the SOS may be a very good tool for providing data in an Inspire compliant way. So Looking at the available guidelines, there's already a document available called the Guidelines for the Use of Observations and Measurements and Sensor Web Enablement Related Standards in Inspire Annex 2 and 3 Data Specification Development. That document mainly focuses on the use of O&M, so on the encoding, how to model the data, how to encode the data using standards like ISO, OGC, O&M, but it does not contain more details on the specification. It has a recommendation that sensor web technology, especially SOS, could be feasible for that, but it does not provide guidance on how to use sensor web technology for making these data specifications also live in the sense of providing these data. So, looking at sensor web, the technological background we have been working on, basically the idea was to reduce the integration efforts you have to put into the integration of your sensor data into any kind of application. Looking at these standards, you can see sensor web or OGC sensor web enablement, which is the framework of standards, as some kind of extension for spatial data infrastructures to also better deal with observation data. And within this framework of standards, there are especially two of relevance. On the one hand, that's the OGC Sensor Observation Service. You have been perhaps working already with Web Feature Service, and the SOS is basically a special interface, a special standard at the OGC for dealing with such observation data. This is complemented by another standard, ISO OGC Observations and Measurements. That's basically a way that describes how to model and encode your data. So looking a bit closer at O&M, it basically defines how to model your observation data, your measurement data, and it says each observation has a specific set of properties that you have to consider. That means every observation has a timestamp. It defines also which types of timestamp you have. It has a value. That value can have different times, perhaps even a unit of measurement, depending on the value type. It has an observed property, so which parameter is observed, that must be encoded. The feature of interest, so the geospatial objects to which this measurement relates. So there are several properties which are defined. That's not a comprehensive list here, just to give you an idea what is defined in O&M. The data model is approved as an ISO standard, so this abstract model, basically the UML part, you could say, and on the other hand, we have an OGC standard which provides an XML encoding of this abstract model. And then, complementary to that, we have the SOS, the Sensor Observation Service interface. That's more for accessing this type of data, so you have your data available somewhere, and with the SOS, you provide a common interface independent of the sensors you are using, independent of the database in which your data is stored. A common interface. You can ask for specific data sets. It has some filtering rules that you can specify which sensor data you would like to access, and this is basically the main intention of the specification. And it relates to these data formats you have seen. O&M is the response format of the SOS interface, at least the default response format. I've also shortly mentioned here SensorML. SensorML is another OGC standard that's for the metadata about the measurement processes. However, that is a bit more complex to look at that because there are different ways to provide the sensor metadata also in the context of Inspire. So that's a bit the technological background, and now the first task that had to be addressed was you had to map the functionality of the download service to the different operations of the SOS. So to describe how can such an Inspire download service be realized through an SOS. So we have these two groups of functionality, predefined access downloads, so that you have complete data sets that you need to download. For that, for getting the download service metadata, of course, like all OGC services, you have get capabilities, get spatial data set, so getting the observation data, the SOS operation which corresponds here is get observation, so you ask for the observation data, describe spatial data set, getting metadata about your data set. That's mainly included in the capabilities already in the SOS, so the get capabilities operation is here sufficient. And link download service for discovering this, that could be done through the catalog service. So that's the first big part. The second part, direct access download. So, for example, doing subsetting on the data that you have there, you can go for the get spatial object operation. That gets immediately covered through the get observation operation. So that means if you have an SOS running, which is Inspire compliant, I will tell you a bit more which extensions would be needed to be Inspire compliant, you immediately get both types of functionality, the predefined data set download and the direct access download. And of course, describe spatial object type is included in the capabilities again. So that was a mapping of the functionality. Then we needed to make also some statement on how to provide map certain specific terms from the technical guidance into the SOS concept. And for that, we had to say first, what is a spatial data set? So which property in an SOS server could be considered as a spatial data set? And the offering, the SOS standard has for that a quite nice feature, which is called observation offering, which allows you to group the content of your SOS server that you are providing into some groups, which can be then considered as a data set. Spatial object, of course, if you are dealing with an SOS or with observation data, the spatial object is an observation you are working with. And the spatial object type, in this case, relates to the observation type. So you have also different types of observations, like measurements, which are related to scalar values. You can also have Boolean values, which correspond to true or false observations. So you can describe different observation types in this context. So looking at the technical guidance, what did we do to the document? We added on the first part this description how the basic functionality of the download service could be mapped to the OGC standard. That's up here. And then we added two chapters. One chapter describing how the predefined dataset download can be realized through the SOS standard, and the second one then the direct access download. So these are the extensions. And looking at the SOS, there are a few things that need to be added to the default OGC SOS interface to become Inspire compliant. You know that also from other services to a certain extent. So Inspire metadata in the capabilities document needs to be provided. That applies to the SOS as well. And SOS needs to, the SOS interface needs to be added by two additional query parameters. On the one hand, you need to be able to query for a certain CRS, a coordinate reference system. That needs to be provided as metadata, which CRS are supported, which request parameters, and you need a request parameter for the SOS operations to specify which CRS you would like. And then the same about the language. You need to provide metadata about the language and also request parameter for getting your data in the language that you would like to have. So that's a very quick overview what is in this technical guidance update, or the proposal for technical guidance update. This was complemented, not only that we do some theoretical specification exercise, it was important to do that together with an implementation. So these specification proposals have been implemented also. They were implemented as an enhancement of the 52 North SOS. That's an open source implementation, which will also be freely available for everyone who would like to set that up. It is also important that we included a quite flexible approach so that you can integrate that into your existing infrastructures. So the idea is that you do not have to restructure your data acquisition network or your databases. Usually, most agencies we have been working with in the past have their data already in some kind of database, and there are quite comfortable mechanisms in play in this implementation, which help you to link your SOS to your existing infrastructure without the need to change anything of the existing components that you have. If you would like to get more information about this, on Monday we already had a workshop. The material of that workshop will be made online available. There we have some further slides also included, which you can look at, or contact us also, where you can learn a bit more which options exist to integrate an SOS in your existing infrastructure. So a core functionality is, for example, that we rely on Hibernate for making it possible to link that software to different database applications, the different database management systems, different database models, so that you easily can apply the software in your own infrastructure. So that's a view what you can do with the SOS as soon as the data is available in such a service. You can, for example, access data from different countries. What we did here is an exercise. There are SOS servers running at the moment in Sweden, in Belgium, and the Netherlands for air quality data. So these are 3 examples of the running services which we are aware of. And here we have loaded data from 3 countries about ozone concentration. I think the yellow one that's from, or the red one is from Belgium, the blue one is from the Netherlands, and the yellow one is from Sweden. And you can easily compare these data from the different countries, do further analysis. There are other clients, not only such web-based viewers. There are, for example, also integration options to link that to tools like R, the statistical language, which can directly consume this data and make that available for further analysis. So there's a lot of different options what you can do with the data. So it's not only about providing the data, there is also real use. If you provide the data, you can really get some benefits of that. So let's come to the conclusion. What we did is look at the SOS as an optimized interface for accessing observation data. Together with the JRC, we have worked on a proposal for an update of the technical guidance for download services. This proposal for an update has been mainly completed now. That is now in the process of being circulated to the MIG, getting feedback there, establishing a dedicated subgroup on that topic. And that's work in progress. However, the basic specification is there, and now it's in the formal discussion process to see if that gets finalized and accepted. There is this open source implementation you can already use. I already mentioned there are additional components available, like the JavaScript client you have seen, SOS for R as an integration into the R framework. And of course, one thing we would like to promote is, especially also as this is a project done in the context of the ARENA framework, we are really looking for countries who would be interested in implementing that, evaluating the specification, looking at that, seeing if there's further need for clarification in some parts, and try out if that's available. And that's also a big driver why the software has been provided as open source software, so that you can easily have a look at that. So with that, I would like to close. If you would like to get further information, there's my email address. You can contact me always. And also, I will be here for the rest of the day if you have any further questions. Thank you.
Thank you. We have a time for a question. The floor have some question about SOS. It's quite interesting topics. So, no questions? Just one thing is not a question, but just to remark something. Your work is including in a MIG activity, so it's one of the tasks of the activity. There's this download service, and have a sub-task for SS.
Yeah.
Exactly. No?
Exactly.
So, okay. Pass to the next one. The next one is Emilio López. Inspired download service on the National Center of Geographic Information in Spain. So another vision of download service.
Okay. Good afternoon. My name is Emilio López. I am the director of the National Center for Geographic Information. This is an organization under the umbrella of the National Geographic Institute of Spain, a small organization. And our objective is to publish and to market the IGM products. No? Is it? Okay, so one day, a few years ago, we decided to implement Inspire seriously. We started to work in our SDI in 2004. Okay, we implemented a lot of view services, web feature service, web coverage service, and on, but they are not obviously Inspire compliant because they were before Inspire directive. So the first step was to identify the available sources. We have a cartographic base at the scale 25,000 and 100,000. But unfortunately, these cartographic base don't have topologic relations. They are divided, updated per tiles, about 4,000 for the whole territory of Spain, and because these databases are designed or are oriented to make maps in paper. There are several themes in this database: hydrography, transport network, buildings, and so on. Another source is the administrative units database with the official boundaries at national, regional, and local level. Another, geographical names with more than 1,250,000 named places. Addresses, we have a collaborative project with other departments, Cadastre, Statistic Department, and the Postal Office, the Postal Codes Office, in order to make the transport network and this network is connected with the street maps of all our urban areas. And we are getting to the addresses. Other digital terrain models, images, and land cover and land use. So these are our source for for develop our services. Next step was to populate a database. In that moment, we were using Oracle Spatial, but we decided to change our technology to PostGIS. The reasons were that using PostGIS we don't have to pay license. And in this crisis, it's a very important issue for our budget. PostGIS provides a lot of functionality that is enough for us. Perhaps it's not as much as Oracle Spatial, but it's enough for our purpose. It provides a good performance, and we are studying nowadays to use PGPool as a load balancer to provide high availability and scalability. The third step was to develop view services. In this case, we have developed WMS and WMTS compliant with the technical guidelines for the implementation of Inspire view services. We are providing Spanish and English capabilities. We are providing metadata for each layer linked to the discovery service. Yes, because I don't tell, but we have developed a catalog service compliant with the technical guidance using GeoNetwork. And in this case, we are using several technology, open source software. Varnish is a cache application to improve the performance of our services. We are using, for implementing our WMS, we are using GeoServer for vector data and MapServer for raster data, and we are using GeoServer for WMTS. So we are populating our database with different sources, and we have view services using these databases and cache service to improve the performance of our services and to improve our service for our users. Okay, so we have the databases, we have the view services, the WMTS, but the next step should be to develop download services, but we have a problem, okay? Because it's not necessary to have structured data, to have data fulfilling Inspire specifications to develop a WMS or WMTS. But it's not possible to develop a download service if you don't have the tools and the data prepared to fulfill Inspire specification. So at this moment, we found a barrier, and we decided to start a transformation process. And this is the moment who we are now. This process consists of analyzing the Inspire UML diagrams, to analyze our data models of our data sources, matching between models. That could seem easy, but it's not easy. We have to fight with a lot of problems. We have to building the physical model and the views and the tables and the attributes that we are going to use in order to prepare it's not an Inspire database, but very close to provide data sets Inspire compliant. And finally, we are using some transformation tool, FME in this case, to populate the database. So, but unfortunately, we have done this work with several of our themes and several of our database, but it's not possible to structure all our data because some of them there are not topological relationships in order to create a network, transport network or hydrography. Some attributes are missing. For example, we have a lot of problems with Inspire identifiers. There are some inconsistencies between tiles because we have updating our data sets using tiles. So the problem is that there are tiles that you can't connect because the date of updating is different in each tile. And there are other problems with the coordinate reference systems, formats for restore data, raster data, and other things. No. Okay. So now, for some of our database, we have structured data, so we can implement WFS. In this case, we are using degree. We are matching between Inspire XML schemas and fields and tables of our database, but in this case, because we have done previous work, we have prepared our database, our tables, attributes, and view tables to do it. It's quite easy, okay? And we have prepared addresses, geographic names, and administrative units. You can play with the URLs that are in our production environment. And I think that in 2 weeks, we will have the transport network at 100,000 scale. Finally, the last step, we decided to inspire our data download center. We are providing all our digital data sets via our data download center since 2007, but with some restriction. You have to register and log in this website. Not only you can download a file per session, but one file each time, okay? Only one file each time. We have two types of data sets. The national reference data set, administrative units, and geographical names that we consider that are basic data and are open and free and without license or a license similar to Creative Commons BY. And we have the rest of our data that are cartographic-based, topographic maps, orthophotos, and so on, that are free but only for non-commercial purpose. The license is more or less the Creative Commons BY, no commerce, share alike. Okay, this website is quite successful. We provide a lot of files and gigabytes each year, and the demand is increasing every year. And there are some, that's important, some FTP service behind this website. But the technical guidelines about predefined dataset download service not say nothing about FTP service, but about ATOM services. Okay, so this year we have implemented the ATOM plus OpenSearch service. We are using the same information of the database. We are providing the same data sets of our website, but in this case using ATOM. Because we are using the same database, we are providing not only vector datasets, but raster dataset, but only for datasets related to Inspire themes. And not always are Inspire compliant datasets. Okay, we provide all our information using ATOM, but for Inspire themes, but not Inspire compliant. So this is the URL and some examples of how to you can see these ATOM files in several browsers. Okay, and finally, next steps. We have to structure the rest of our data at 25 scale in order to provide Inspire requirements. There are a big project in not in my organization, but in the National Geographic Institute, in order to change our production process from oriented to paper maps to oriented to build layers. Okay, so we have a big change, and it's necessary for us in order to provide data Inspire compliant. When we have all our data prepared to be Inspire compliant, we will be able to provide WFS at not only a small scale, but big scales for hydrography and transport network, and our ATOM plus OpenSearch service will provide Inspire datasets. We are working in order to provide new service adding value based on our WFS, trying to improve or to fill the gap between us and the users. We have some problems with ATOM. I think that the technical guidance for predefined datasets should be improved for different formats and for multiple files, because I think that it's not good enough. Okay, and finally, we have to improve our data policy. Why? Because we have seen that we are not getting a lot of money selling digital data. our digital data set, because if you are not going to use for non-commercial purpose, it's free, and because a few years ago Google and TomTom and Garmin take our data and never come again to pay more. Okay, so it's not our business. This is not going to take out of the crisis, and within that the business model is around the services, the training, the consultancy, and these type of services around the data sets. So I hope that slowly, but we are going to an open data policy. Okay, and that's all. Thank you for your attention.
Thank you. We have time for a question.
Hello, I'm Gianni Campanile from Esri, Italy. My question is, at what level did you define your downloads, your Atom download service? Did you, for example, did you prepare all the complete iGeography database to download, or only some data sets, or something more wide? How did you choose the level at which provide the data with the Atom sets?
Okay, we are. I'm not sure. I think that we are providing all our data that are in our data download center, not but related to inspired themes. And I think that we are providing both at all the scale that we have. Okay.
Yeah, that's okay. But you can, with Atom, you can prepare one Atom file that contains all reference to all data sets, or you can have one Atom file for each data set, or you can choose. My question is,
we have only one Atom for the service and one Atom for each data set, about 17, I think, or more or less. Okay. And for example, for the one product is the orthophotos of Spain, and there are only one Atom, and then there are entries in this Atom, but there are 1,000 entries in this Atom, because we think that one orthophoto is not a data set; it's a tile of a data set.
That's exactly my question.
We think that is a problem.
Yeah, exactly my question, because the decision on at which level to build an Atom, if it is for each tile or for all tiles, it's not really clear. It depends.
Yes, but if, for example, our cartographic base has about 25,000, has about 4,000 tiles. The topographic map, another 4,000 tiles. It's impossible to, well, it's a very hard work to prepare one Atom for each tile. Okay. Thank you.
Okay. One more question. No questions? Okay.
When you talked about the conformity of WMS, which tool did you use to assess the conformity?
Okay, no, manually conformance test application. No, we have developed a test validator. Okay, but finally, I think, I'm not sure, that we are using an API that the European validator provide. But we say that is a conformance service because we think that is true. No,
okay, thank you.
No, because a tool say that.
We trust on you. Thank you.
Okay, to the next and last presentation. Clemens Portele, experience with publish inspired data for use in apps.
Thank you very much. Obviously, my head is in a different shape than the others, so it took a while to get the microphone fixed. Yeah, I'm the last presentation, so the last talk between now and the beer. And I will be talking about experiences with publishing inspired data for the use with apps or applications. Really, I used apps because mostly what we think of is our focused small types of applications. It's actually a continuation of a talk I gave at the Inspire conference last year, which was called How to Use Inspire Data, which was mostly looking at the situation that we have in the directive, and then as a follow-on in implementing rules and in the technical guidance documents. And really, the point is and was and still is that what they cover is the provider side, but they mostly ignore the user side because they talk about obligations, and that's affecting the provider side. But there is actually a lack of guidance and also tool support, as we have heard before, in actually how to use the Inspire data as we have seen today. So that's already also from last year. We identified there in that work several patterns how Inspire data can be used directly in applications, be that mobile or web applications or rich clients. One part that I will be mostly talking about is basically the right-hand side, where what you actually do is you take the data, and it's called download service for a reason. Really, one of the limitations is, as you have also identified, I think, Jiri, there are some struggles in the way it is designed. If you want to use that data directly in apps, it's called a download service for a reason. It's meant to be downloading data and then using that. But of course, with the web, people are expecting, if the data is on the web, that they can use it directly. There are several. One way of doing that is actually to take the data and move it into an environment. Here we're using a cloud-based environment, which can then be used directly and easily by applications, and that is designed for that purpose. Other aspects are that you can also improve the view services, so they don't just use the layer style that's in the technical guidance, not just the layer names, layer structures that's in the implementing rule, and etc., and also then the capacity as needed, and also to go beyond, obviously, atom feeds, but also support direct access download services, and then if the performance is right, you can use that also directly in applications. So one project is ELF, European Location Framework, that's been mentioned in a number of presentations during this week, where we are actually looking into these patterns and trying to see how they work and make them work. So the ELF platform that you see in right in the middle here, that's basically the classic Inspire network services. So you have the WFSs, WMTSs, WMSs with the reference data from national mapping and cadastral authorities. We have seen two of them here from Czech Republic and Spain. They are part of the project, and these services that you've seen are also part of that infrastructure that you see here. So what we do here is go one step further and actually take the data from this distributed environment and move it into a cloud-based environment. We're using ArcGIS Online here to integrate, cache the data there so that we have it with high performance and reliable performance. That we have it in structures that works directly with many applications. It supports, oops, that was the wrong button. that works with a lot of APIs that we have, JavaScript, the mobile SDKs, etc. So we want to bring Inspire data from the downloading to an environment where it's ready to be used directly in very demanding applications and on all sorts of devices. What ELF is about reference data. So basically we see three different important patterns for using reference data. The first one is basically you just create a base map. So reference is just in our eyes or the brain when we see it. So you lay your data on top of a base map, but there is no real interaction with the base data. I'm not really going to look at that topic. The second one is really that we use the reference data to actually georeference other data or geocode other data. For example, statistical data, potentially also other transport network data that has linear referencing to certain parts of our road network. So that also has very limited needs from the Inspire data. Basically, we just need the identifier so that we can identify the links between the other business data and the Inspire data. And of course the geometry to do the georeferencing. And the final one the third one is to use the feature data directly in applications. So you have your mobile apps that talk directly to one of the services and interact with the data by querying, by visualizing it, etc. So when we look at what developers really want, what you see down there is really the gist that, in particular, when we look at developers who are not really Inspire experts, so they are probably not here at the conference, but they just want to get some data and integrate it into their environment. So if you point them to the Inspire specifications and or the OGC specifications, they will quickly give up because they don't know where to start or to end. So that's why we picked also ArcGIS as an environment, because we have very good documentation that is there, and it supports all the different mobile devices. It supports the major operating systems, Windows and OS X or Java, and also the dominant web environment, JavaScript and HTML5. There are, of course, others. So that's basically a pattern for using Inspire. And I think the key part that I think is important is that you have broad support for all the different platforms. You have very good documentation, sample code. You have an active developer community, so that you really have an easy way to develop your applications on top of that. And there are potentially other Google Maps engine, etc., other environments where you can get that done. So I have a simple video. I leave that. You can watch that later, just showing how you can take one of the ELF feature services and create that's a 90-second video, and then how to create in JavaScript using the website, the documentation, the sample code there. Quite nice apps in a very short time. I want to talk a little bit about what we're doing when we go from the Inspire data to the data stores in ArcGIS Online. So I think there are 4 patterns that we apply here that I'm discussing. There are more, but the key ones that we have been used so far are, first of all, that we flatten the structures. So we don't have the deep nesting of properties, complex properties. We flatten the structures. That's the way ArcGIS and the environment mostly works. But at the same time, that's also how most other client environments that use GIS and map-based applications really work. So we make it more simple to actually work with the data, and part of that is also to reduce the data. So we're really looking into, for example, for which parts of the data do we have coverage in many countries, which part is really relevant for applications that we're aware of. I probably should mention that as part of the work in the European Location Framework, project, we are not developing the apps. We're providing that framework, and there are other organizations who will be developing applications on top of that. And what we only do is try to develop demonstrators, support the other organizations if they have questions. But we look at the data that is there from the national mapping authorities and what is valuable, and we reduce it to that, because otherwise it's quickly that people are also they're overwhelmed by the data and structures. An example is geographic names. That's I think that gave headaches to quite a few who did data transformations and service provisioning. So that's actually from one of your services, Jiri, from the Cadastro. I think it's from it's from the administrative unit one. So that's a geographical name that we have in there, and lots of information, endonyms, whether the name is official, and for most applications, that doesn't matter, right? We actually just take two items, which is the actual name and the language. That's the only two things that we take out, because that is sufficient for almost all applications that, in particular, that application developers will be interested in. So that's an example. And we also restricted in Inspire, it's you have unlimited multiplicity. We restrict it to 2 or 3 names. Right now I think we have 2, probably we'll extend that to 3. So that's one example, probably hard to read, but that's the Brussels build-up area, and you have a name in Dutch, Brussels, and one in French, which is also Brussels. And that's basically it. But you have a flat structure, you have the multiplicity simplified, so that's much easier to handle for the users. And here it's also, since ArcGIS is using JSON as the encoding, so you also see here the JSON here with the aliases that's been converted to readable names. But that's what you have here, simplified structures and flattened structures. Another example also from the administrative unit, that's the WFS basically from the Czech Republic, is what we do is we make layers explicit. So as a conceptual model, what Inspire does is we have an administrative unit feature type. That's great, because whether you're on level 6 or on level 1, it's all administrative units. But if I point my client to a WFS, actually that's probably 6 layers of administrative units on top of each other, and in a map-based client it's hard to read that. So we have here administrative unit, but they're all on top of each other. So when we target map-based clients and have these structures where usually in a map-based application you see a sequence of scales where you will see different, usually different levels depending on the size of the objects. So we are actually splitting it up, the administrative units, in 6 layers, because that's the levels that Inspire uses, and also then statistical units in 5 with the nuts and the Lau regions. So that's basically also one change that we do to make it easier for application developers to use the data. The other thing that is important is that the API that ArcGIS Online uses is very well for developing apps that directly consume these services. So the GeoService or ArcGIS REST API feature service, it basically provides the capability of a direct access download service. It supports queries. You can filter the features that you're interested in by spatial and thematic attributes. But it also has several other capabilities that are very, very useful to have applications with a good user experience. So one is HTTP caching. So when panning and zooming, that's greatly improved. You have the generalization of geometries. You can pass on the map scale that you're at, and then you get far less coordinates. For example, when you look at the Czech Republic, the whole area, and then zoomed out, then you don't need everything, because you won't see most of the vertices that are drawn. And also then you have scale and rendering rendering hints that already give you with every layer an idea of what's the proper scale and how should it look like. So that's how it looks like. If you go to that URI, you will get there. You see a little bit less because not all of that is publicly available. But ELF maps arcgis.com, that's where you get the data, and we'll be adding additional things in the future. Here, just a few examples, sample layers from Euro Global Map. That's open data. You can see that, and included 3 feature types in there. You can look at that when you go to the URI. That's statistical and administrative units on top of a base map that's created from the European data. And here, that's actually data that has been georeferenced, data from Eurostat, population density data that is accessed from Eurostat directly by an FME process that's running an FME cloud. It accesses the statistical unit in ArcGIS Online and writes back another feature service that I can then access online and use then in my web maps or applications. To conclude, there's one other option that's not really part of what we do in ELF, but there's another option because we have always had the problem that we have the web feature services and it's difficult to get them into the clients that we're typically using. So we have developed as Interactive Instruments a product that we'll release next month, which is Extra Proxy, which basically accesses the WFS but looks like an ArcGIS GeoService REST API feature service. So you can use that in the classic typical clients, mobile, desktop, and web. And there we do basically the same things. We automatically flatten the structures so they work in the clients. You can configure it to remove attributes. But what we do is we maintain the structure in the pop-ups. So that's again from the Czech Republic Administrative Unit WFS. You can still see in the HTML pop-up. You can see the structure of the Inspire data. Okay, that's with that I conclude my presentation.
So thank you. We have a time for a question. Okay, Emilio.
Okay, I have a question about the JavaScript. Are you thinking to develop a JavaScript to hide the complexity of the coordinate reference system, of the formats, in order to fill the gap between IT developers and the services provided by the ELF?
No, I mean what we want to do is we want to move the Inspire data into the ArcGIS platform in a way that is completely the way everyone else publishes in that platform, so that a developer who follows the guidance that you find on all the websites that you can use, where you use the tool, including the JavaScript API, it works with all the other data. So also what we do is the data is published using, not in ETRS 89 or something, but using the web Mercator that I think almost everyone is using for if you look at Google Maps or the Esri maps, we're using web Mercator for these presentations. But the services, they do also coordinate transformation, so you can also ask for the data in ETRS 89. So it's there, and the JavaScript API supports using that. So there is built-in support in the ArcGIS JavaScript API to handle all that.
A second question?
Yeah.
Okay. You talk about to flatten the features, but for view services and for download services, for both of them, or only for view services?
No, for the download service. But basically, I don't call that a download service anymore, because it's the connotation of download service is you download data sets, and this is mostly to make it available as feature services so that applications can interact with them. But these are flattened, right? So you have flat feature structures. Currently we produce a base map, that's a tiled map service, but I'm not sure if we will continue to do that. Maybe there is, as part of the ELF platform, there will be a WMTS, and if that works well and looks fine, then we can also use that directly and don't need to do any view service development on our own.
Okay, but it will be possible to provide Inspire compliant data sets? Because we are going to
we have a structure. We have a transformation. So we'll be using FME or ArcGIS to actually transform that. We are accessing the WFSs and then change the data and upload it to ArcGIS Online in that flattened structure and simplified structure.
Okay. Just a very quick question, I suppose.
Yeah, it's Arvid from Norway. So, as I understand, yeah, you are recommending here the REST APIs, and you also recommend you're looking for. I don't see so much of GML here, and of this deliveries, and how. What are we losing in this way of distributing information, and what are we gaining, and what should we do to modernize Inspire, because with the specifications we have today?
Okay, I mean it's not really about doing one thing and not doing the other thing, right? So we see that as an on-top option. And I think that whatever we will do, there will always be more environments where people will be developing application and needing Inspire data. I think it's an illusion that will create this one infrastructure and everybody will be using that and will be easily able to use that. There will always be a set of technologies and different environments. So what we're here mostly interested in, and also trying to learn that as part of this project, can we build the bridges, right? So that we can, there is an ecosystem that lives based on WFS, WMS, etc. And it's not going to say that this is wrong. But in particular, since we're simplifying things, there will always be applications that need the full thing. But we're really looking at some things where a large group of users or application developers don't need the full thing. So we're looking for options to make it easy for them, and also to make Inspire really useful. So it's rather an additional option that is, I think, what we want to bring here to the table and up for discussion. So I don't see that as a battle or conflict, right? I mean, we also have a WFS implementation and WMS implementation, and that's widely used, but we want to extend the reach.
But we might change direction also in Inspire.
Well, it could be. I think it's what it might be of interest is to say, okay, when we say what are the possible download services or view services, could we also extend that? I mean, I think basically this will be market driven, right? It's if the community is using certain things a lot and it proves useful, then I would expect that also technical guidance will reflect reality in some way. So I think I think we are all learning as we go. But this is kind of I think it's an important aspect that we as a community implementing Inspire need to be aware of and look at.
Okay. I think so. If you have a question, you can ask after the session in the coffee break or during the poster section. We have time. So thank you for all the presenters, all the people that come in the session, including this section, and thank you again.
Thanks, guys.